Try to imagine nothing. Not darkness. Darkness is something. Not empty space. Space is something. Not silence. Silence is the absence of sound in a place where sound could exist. Try to imagine the absence of space itself. The absence of time. The absence of the possibility of anything. You can't do it. Your mind reaches for an image and finds the image requires a stage. It requires somewhere for the nothing to be. It requires a moment for the nothing to exist in. This is not a failure of imagination. This is the wall every physicist in history has hit when they ask the same question. What was there before the Big Bang? For most of human history, the universe was eternal. No one questioned it seriously. It had always been there. It would always be there. The stars were fixed, the heavens were permanent, and the question of a beginning simply didn't arise. Then, in 1929, an astronomer named Edwin Hubble made an observation that changed everything. He found that galaxies were moving away from each other, that the universe was expanding. If it was expanding now, it had been smaller before. Run the film backwards. Everything that exists was once compressed into a single point, a point of infinite density, infinite temperature, infinite curvature, and then, approximately 13.8 billion years ago, it expanded. This became known as the Big Bang, and it immediately produced a problem no one was prepared for. If all of space began at that point, and if time is a property of space, which Einstein had shown it to be, then time itself began at the Big Bang. There was no before. The word doesn't apply. The question assumes a structure that does not exist there. And yet physicists kept asking, because the answer turned out to be more unsettling than the question. In 1970, Stephen Hawking and Roger Penrose published a paper in the Proceedings of the Royal Society. Using the mathematics of general relativity, they proved something disturbing. If Einstein's equations are correct, space-time must contain singularities. Points where the curvature of space becomes infinite, where the known laws of physics do not just break down, they cease to apply. The Big Bang was one of these points. The equations went there and stopped working. This was not an approximation error. It was a mathematical proof. At the very beginning of the universe, physics as we know it had no jurisdiction. 13 years later, in 1983, Hawking and James Hartle at the University of California proposed something stranger still. They applied quantum mechanics, the physics of the very small, to the universe as a whole. And in their model, something unusual happened to time. Near the Big Bang, time did not stop. It did not hit a wall. It became something more like a spatial dimension, curved. And in curved imaginary time, the concept of a beginning dissolves. The universe, in their model, has no boundary, no edge in time, no moment before which there was something else. It is finite, but without beginning, the way the surface of the Earth is finite but has no edge. Hawking described it this way: asking what happened before the Big Bang is like asking what is south of the South Pole. It is not that the answer is unknown. It is that the question does not correspond to anything real. The universe Hartle and Hawking proposed simply is. It has always simply been. But here is where it gets stranger. In 2006, Abhay Ashtekar at Pennsylvania State University, working with Tomasz Pawlowski and Parampreet Singh, published a paper in Physical Review D that approached the same question from a completely different direction. Ashtekar had been working on something called loop quantum cosmology, a framework that attempts to apply quantum mechanics not just to particles but to the fabric of space itself. In quantum mechanics, energy comes in discrete packets. Ashtekar proposed that space might too, that there is a minimum unit of space, a quantum of space, below which you cannot subdivide further. When his team ran the equations of the Big Bang with this constraint in place, something unexpected happened. They approached the singularity, the point where classical physics breaks, and instead of breaking, the equations bounced. Matter, in this framework, cannot be compressed to infinite density. At scales billions of times smaller than a proton, it hits the quantum floor of space itself. And when Ashtekar and his colleagues followed the equations through that floor, they found something on the other side, a previous universe. In loop quantum cosmology, the Big Bang is not the beginning. It is the midpoint, a universe that existed before ours, which may have had its own stars, its own galaxies, its own hundreds of billions of years, contracted under gravity to a point of extreme but finite density, hit the quantum limit and bounced. The expansion that followed is what we call the Big Bang. We are living in the echo of something that ended. Think about that for a moment. Every photon that has ever warmed your face, every atom in every object you have ever touched, all of it may have passed through the compression of a previous universe, on the other side of the boundary we used to call the beginning of everything. This is the ground you are standing on right now. Not metaphorically. The carbon in your cells was forged inside stars that burned and exploded before the Earth existed. The iron in your blood was produced in stellar collisions that predate the solar system by billions of years. You already knew your atoms were ancient. What these models suggest is that they may be older than the universe itself, that the material reality you are made of passed through the compression of another cosmos entirely. The reason the question feels impossible is that your brain was built to navigate a world of medium-sized objects moving at medium speeds in the comfortable middle of space-time. It was not built for the edges. The words before, after, beginning, end, all of them assume time is a river with a source. Several physicists are now telling us it might be a lake, or a sphere, or something for which no human language has a word, because no human has ever needed one. The question is not too hard to answer. It may be too large for the instrument we are using to ask it. There is one final answer, and it is the most disorienting of all. In 1981, Alan Guth at MIT proposed that the universe, in its very first fractions of a second, underwent a period of exponential expansion called inflation. In an unimaginably short interval, a region of space smaller than an atom stretched to the size of a grapefruit and beyond. The theory solved problems that had puzzled cosmologists for decades. It explained why the universe is so geometrically flat, why the temperature of the cosmic microwave background is so uniform in every direction, why the large-scale structure of galaxies looks the way it does. But inflation, once it starts, does not stop everywhere at once. In 2007, Guth published a paper demonstrating the implications of what he called eternal inflation. In most models of the universe's earliest moments, inflation ends in some regions and keeps going in others. Each region where it ends collapses into a separate universe, a pocket universe with its own laws of physics, its own constants, its own potential for stars and planets and life. The process continues indefinitely. There is no edge to it, no moment when it began. An infinite landscape of universes, forever inflating, forever producing new ones. In this model, there is no answer to what came before the Big Bang. Not because the question is forbidden, but because the answer is everything. The same process that created this universe has been creating universes without beginning and without end. Our Big Bang was not the beginning. It was just a Tuesday. Every model physicists have built to answer this question agrees on one thing. What you can see is not all there is. The observable universe is 93 billion light-years across. That is everything that light has ever reached us from in the 13.8 billion years since the Big Bang. It is so large that the number has no meaning to the human brain, and it may be the tiniest fraction of what exists. The physicists who have spent their lives on this question do not agree on an answer. They agree only that the boundary is real, that something exists on the other side of it, and that the word before may not be the right word for what they are trying to describe. You are somewhere in the middle of something with no edges. You have always been. And the universe, whatever it is, has been going on without you noticing for longer than time itself.